So today we are studying composition and structure of atmosphere. It is chapter 7 of physical geography of class 11 Ncert. So let's start. Can a person live without air? Wow. So basic. We eat food 2 or 3 times a day and drink water more frequently but breathe every few seconds. Air is essential to the survival of our organism. Some organisms like human may survive for some time without food and water but cannot survive even a few minutes without breathing air. That show just shows the reason why we should understand the atmosphere in great details. Atmosphere is a mixture of different gases and it envelops the earth all around. It contains life-giving gases like oxygen for humans and animals and carbon dioxide for plants. Air is an integral part of the Earth's mass and 99% of the total mass of the atmosphere is confined to the height of 32 kilometers from the Earth's surface. So let's get a view of this chapter first. Like get the structure of the chapter. First is it just gives the detail about the importance of air. Second is the composition of the atmosphere. Now gases, carbon dioxide, water vapor, dust particles. Now structure of the atmosphere. Next. Okay, we have gone through the structure. What's next? Oh, just this one. This chapter is so small, like I can finish it in one reading. Okay, I will do it. We'll do it. So, uh, let's keep on marking that important stuff, like the fun, uh, important stuff is the height of 32 kilometers from the Earth's surface is atmosphere is confined. Atmosphere is confined to the height of 32 kilometers from the Earth's surface. The air is colorless and odorless and cannot be felt only by can be felt only when it blows as wind. So moving air is called wind. Can you imagine what will happen to us if the us in the absence of ozone in atmosphere? So, will get burned by ultraviolet rays because most of the ultraviolet rays is absorbed by our ozone layer. Composition of the atmosphere. Atmosphere is composed of gases, water vapor, and dust particles. Proportion of the gases change in higher layer of atmosphere in such a way that oxygen will be almost negligible. So sorry. That oxygen will almost in negligible quantity at height of 120 kilometers. So the basic atmosphere is confined till the height of 32 kilometers from the earth, but still above it some traces of oxygen will be found, but it is almost negligible in the height of 120 kilometers from the surface of earth. Similarly, carbon dioxide and water vapor are only found up to 90 kilometers from the surface of earth. Next, now gases. Carbon dioxide is meteor meteorologically very important gas it is as it is transparent to the incoming solar radiation but opaque to outgoing terrestrial radiation. So it absorbs a part of terrestrial radiation and reflects back some of it toward the Earth's surface. It is largely responsible for greenhouse effect. The volume of other gases is constant, but the volume of carbon dioxide has been rising in the past few decades, mainly because of the burning of fossil fuels. This has also increased the temperature of the air. Ozone is another important component of the atmosphere found between ozone is found between 8 to between 10 to 50 kilometers above the Earth's surface and act as a filter and absorbs ultraviolet rays radiating from the sun and prevent them from reaching the surface of Earth. Next is water vapor. Water vapor is a variable gas in the atmosphere which decreases with altitude. In the warm and wet tropics, it may account for 4% of the air by volume, while in dry and cold areas of desert and polar region, it may be less than 1% of the air. Water vapor is Water vapor also decreases from the equator toward the poles. So it decreases from equator toward the pole. It also absorbs parts of isolation from the It also absorbs parts of the isolation from the sun and preserve the Earth's radiated heat. Thus, act as a blanket, allowing Earth neither to become too cold nor too hot. Excuse me. Water vapor also contributes to the stability and instability in the air. Now, our next is dust particles. Atmosphere has sufficient capacity to keep small solid particles, which may originate from different sources and include sea, salt, fine soil, smoke chute, ash, pollen, dust, and disintegrated particles or meteors. Dust particles are generally concentrated in lower layer of the atmosphere. So it is basically concentrated in the lower layer of the atmosphere, mostly in Delhi. Yet conventional air current may transport them to greater heights. The higher the concentration of the dust particle is found in a subtropical or temperate region due to dry wind, in comparison to equatorial and polar region. Dust and salt particle act as a hygroscopic nuclei around water vapor condenses to produce cloud. So the dust and salt particle act as a hygroscopic nuclei around which water vapor condenses and produces cloud. Now this is the most important part of the chapter. The structure of the atmosphere. The atmosphere consists of different layers with varying density. The atmosphere consists of different layers with varying density and temperature. The density is higher near the surface of the Earth and decreases with increase in altitude. So as we go above the Earth's surface, the density of the air decreases. So it is higher. Density is higher at the surface. Is higher near the surface of the Earth and decreases with increase in altitude. The column of atmosphere is divided into different layers depending upon the temperature condition. So they are troposphere, stratosphere, mesosphere, thermosphere, and lastly exosphere. Troposphere is the lowest layer of the atmosphere. Let's mark it as, since it is near. Is it a good color? Yeah, it is a good one. Since the troposphere is the lowest layer of the atmosphere, its average height is 13. But 13 is the lowest layer of the atmosphere. Its average height is 13 kilometer and extend roughly to the height of 8 kilometers near the poles. And about 8 kilometer at the 18 kilometer at the equator. So average is 13. The thickness of troposphere is greater at the equator. Thickness of troposphere is greater at the equator. Is greater at the equator because heat is transported to great heights. Because heat is transported to great heights by strong conventional current. This layer contains dust particle, water vapor, and water vapor. All changes in climate and weather take place in this layer. So all changes in climate and weather take place in this layer. The temperature in this layer decreases at the rate of 1 degrees centigrade to for every 165 kilometers of height. This is the most important layer for all biological activities. The zone separates the troposphere. The zone separating the troposphere from stratosphere is called tropopause. So let's do it right one. The zone separating the troposphere from stratosphere is known as tropopause. Tropopause. The air temperature at the tropopause is about -80 degrees Celsius over the equator and -45 degrees over the poles. The temperature here is nearly constant, hence it is called tropopause. This layer. So in this particular layer, the temperature is constant. Now the stratosphere found here is above the tropopause. Extend the tropopause. Now let's select a good color. The stratosphere is found above the tropopause and extend up to the height of 50 kilometers. One important feature of the stratosphere is that it contains the ozone layer. Let's do it a green because this is one height of 50 kilometers. Stratosphere contains the ozone layer. This layer absorbs the ultraviolet radiation and shield Earth from the shield life on Earth from intense and harmful form of energy. Now, after this lies the mesosphere lies above the stratosphere, which extend up to the height of the mesosphere lies above stratosphere, extends up to the height of 80 kilometers. In this layer, once again, temperatures start decreasing with increase in altitude and reaching up to -100 degrees Celsius at the height of 80 kilometers. The upper limit of mesosphere is called mesopause. So sorry. The upper limit of mesosphere is known as mesopause. The ionosphere. The ionosphere is located between the ionosphere is located. This is something. The ionosphere. Is it the same? Yeah, it's the same. We'll go with the ionosphere is located between 80 to 400 kilometers, 80 to 400 kilometers above menopause. It contains electrically charged particles known as ions. Hence, it is known as it contains electric known as ions. Hence it is known as ionosphere. Radio waves transmitted from Earth are reflected back to the Earth by this layer. So, radio waves transmitted from the Earth are reflected back to the Earth due to this layer. Temperature here start increasing with height. As we saw before, the temperature starts decreasing as we go on height, but after the ionosphere, here start increasing. After the ionosphere, as we go up, the temperature starts to increase. The uppermost layer of this atmosphere is thermosphere. The uppermost layer of the atmosphere above the atmosphere above the thermosphere is non-exosphere. So I think after the mesosphere we get mesopause. The ionosphere is located between 80 to 400 kilometers. This one is ionosphere. This is the highest layer, but very little known about it. Whenever content, whatever content are there, these are extremely rarefied in this layer. Whatever contents are there, these are extremely rarefied in this layer. It gradually merges with the outer space. Although all the layer of the atmosphere must be exercising influence on us, geographers are concerned with two layers, the first two layers of the atmosphere. Elements of weather and climate. The main element of the atmosphere are the main element of atmosphere which are subject to change and influence human on the earth are temperature, wind and humidity, cloud, precipitation. We'll read that in detail in chapter 8. That is the next chapter itself. So it's only 18 minutes since we started this chapter and it is over. We have plenty of time to cover chapter number 8. So let's start with which one of the following gas constituent is a major portion of the atmosphere. So it is nitrogen. Atmospheric layer important for human being is ionosphere. I think the most important layer is mesosphere, I guess. The layer which has the protection of ozone layer is the most important, because without it the life on earth will get destroyed. So here it is. The stratosphere is found above troposphere. Section at the height of 50 kilometers. Most important feature of stratosphere is contain ozone layers. So it is the most important thing. The answer lies with the stratosphere. Let's write it as it contains ozone layer which protects the life on Earth. Okay. The sea, salt, pollen, ashes, smoke, soot are fine soil. These are associated with dust particles. Oxygen is negligible quantity in the height of we have read that somewhere that is 120 kilometers. Yes, it is 120 kilometers somewhere in the first chapter where negligible. Yes. Which one of the following gases is transparent to the incoming solar radiation and opaque to out? This is carbon dioxide. It is transparent for the incoming solar radiation and opaque to the outgoing terrestrial radiation. Hence, it is a good for important for greenhouse effect as it maintains the heat of the earth for a greenhouse effect. Yes. So it largely responsible for greenhouse effect. Volume of other gases is constant, but carbon dioxide rising partially beneath. Okay. Greenhouse effect is good and bad also. What do you understand by atmosphere? Atmosphere is made of a bunch of layers. In the first layer, we are surviving due to the first layer. It has oxygen, which we breathe. What is the element of weather and climate? This question is in the last one. Element of the main element of atmosphere, which are subject to change, which influence human life on Earth, are temperature, pressure. This is question 2 also. Describe the composition of atmosphere. Composition of atmosphere is, let's see, what is the composition of atmosphere? The integral part of Earth mass and 95% of the mass. Composition is 99% is the mass atmosphere. Okay, this one is the composition atmosphere. So real right composition is first of all is this gases, then water vapor, and lastly the dust particles. Describe the composition of the atmosphere. Wow, again the same question. So we have to write this in detail. A physical diagram for the atmosphere and label and describe it. Okay, this can be done easily. Since I have read this, I will. What's today's date? Today is 28. So the next date will be 29. And after 3 days, it will be on the first. 3 plus 4, and last date will be 4. Now, chapter number 8, solar radiation, heat balance and temperature. Do you feel air around you? And do you know that we live at the bottom of huge pile of air? We inhale and exhale, but we do not feel the air when it is in motion. But we feel the air when it is in motion. It means the air is in motion is when we have already learned about the fact that the earth is surrounded by air all around. This envelops the air is atmosphere, which is composed of numerous gases. These gases support life over the earth's surface. The earth receives almost all its energy from the earth's sun. The earth in turn radiates back to the space the energy received from the sun. As a result, earth neither warms up nor does it get cooled down over a period of time. Thus, the amount of heat received by different parts of the earth is not the same. This variation causes pressure difference in the atmosphere. This leads to transfer of heat from one region to another by wind. This chapter explains the process of heating and cooling of atmosphere and the resultant temperature distribution over the Earth's surface. First, we'll read. Let's go about the structure of the chapter. The chapter deals with solar radiation, heat balance, and temperature. Okay, the first thing we are reading is solar radiation. Now the next is, so we have already read solar radiation. So our stratosphere shield us from the ultraviolet rays, which is also a radiation types of radiations. Variability in isolation at Earth surface, at the surface of Earth. Variability of isolation at the surface of Earth. Okay, got it. And the next topic is the passage of solar radiation. And the next one is passage of solar radiation through the atmosphere. Okay. This is partial distribution of isolation at the Earth's surface. Partial distribution of insolation, not isolation, is insolation. So did I read wrong? Yes, insolation. So sorry. So variability of insolation at the surface of Earth. Okay, next is heating and cooling atmosphere. This is the next one. So how heating and cooling will occur, we'll read it in due time. Heating budget of Earth's planet. So this explains the heating budget of Earth's. The reflected amount of radiation is called albedo of the Earth. Albedo. Variation in the net heat budget at the Earth's surface. Okay. Temperature factor controlling temperature distribution. Now the latitude, longitude, altitude, distance from the sea, air masses, ocean current, distribution of temperature. Now isotherms. What are isotherms? We are going to read that. And basically that's about it. Okay, not it. Okay, these are the different temperature differences, distributions of the surface, distribution of surface air temperature in month of July, January and July. So inversion of temperature. Next is now the Planck's. This is kind of important. We'll mark this whole into P and we read it. So let's go back. Solar radiation. The Earth's surface receives most of its energy in short wavelength. So the Earth's surface receives most of its energy in short wavelength. The energy received by the Earth is known as incoming solar radiation, which is short in terms of which in short it is the term called insolation. That's one insolation. So we are so the solar radiation that is received by the Earth is called insolation. Basically, as the Earth is a geoid resemblance of a sphere, the sun rays fall obliquely. The sun rays fall obliquely at the top of the atmosphere, and the Earth intercepts. A very small portion of the sun's energy. On an average, Earth receives. On an average, let's change the color and mark this important. On an average, the Earth receives 1.9 calories per. This is energy in per square centimeter per minute at top of its atmosphere. The solar output received at the top of the atmosphere varies slightly in years due to variation in distance between Earth and the Sun. That is a revolution of the Earth around the Sun. So at different revolution at different time of the calendar or month, the distance between the Earth and the Sun varies. So that is the variation of distance. So during its revolution around the Sun, the Earth is farthest from the Sun, that is 152 million kilometers on 4th of July. Oh, Independent Day of America. The position of Earth is called farthest. So let's try this. To hmm. And on 3rd January, the Earth is nearest to the Sun. This position is called perihelion. 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 Now aphelion, epi, epi, ephelion, perihelion, helion, Lion, aphelion, aphelion and perihelion. Okay. This is helion, but it's written as lion. Uh, Whatever it is. Therefore, the annual isolation received by the Earth on the 3rd January is slightly more than the amount received on 4th of July. However, the effect of this variation in solar output is masked by other factors like the distribution of land and the sea and the atmospheric circulation. And this variation in solar output does not have great effect on daily weather changes on the surface of Earth. So the position of Earth is not that much of a does not play that much of a role, uh, so be to call that this at this time period, uh, like there is not much changes, not much difference. Okay, moving on. However, does not have a great effect on daily weather. So let's go to next topic. Variability of insolation. Variability of insolation at the surface of Earth. Let's see. The amount and the intensity of isolation vary during the day, in season, and in a year. The factors that cause these variation in isolation are: the first one is the rotation of the Earth on its axis, the angle of the inclination of the sun ray. The angle determines the main thing. So next is the angle of inclination of the Earth's ray. And next is the length of the day. So we have July something is the longest, mid of July is the longest day in the year. And transparency of the atmosphere. The more transparent, the more easily the energy is passed through the layers of atmosphere. That is the next is the configuration of the land in terms of its aspect. Like if it is on the equator, or however the last two however have less influence. The fact that Earth axis makes it angle of 60, the fact that Earth axis makes an angle of 66 and half 60 half with the plane of its orbit around the Sun has great influence on the amount of isolation received at different latitude. The second factor that determines the amount of isolation received at the second factor that determines the amount of isolation received is the angle of inclination of the ray. Uh, this depends on the latitude of the place. Higher the latitude, higher the latitude, less is the angle. So as we See latitude, higher the latitude, the latitude is the most and at the above. So higher the latitude, higher the latitude. Latitude here is highest. Here is highest. Here it is highest. Uh, Less is the angle they make with the surface of Earth, resulting in slanting rays. Okay. The areas covered by vertical rays is always less than the slanting ray. The area covered by vertical rays, the area is covered by the vertical ray, that is a ray, this much area, is always less than the slanting ray. Slant ray. The more area is covered, the energy gets distributed and the net energy received per unit area is decreases. Moreover, slant rays are required to pass through greater depth of atmosphere, resulting in more absorption and scattering and diffusion. So, the passage of the passage the passage of solar radiation through the atmosphere. So, let's see how this solar radiation passes through the atmosphere. The atmosphere is largely transparent to short wave solar radiation. Okay, so the incoming solar radiation passes through atmosphere before striking the Earth's surface. Within the troposphere, water vapor, ozone, and other gases absorb much of the near infrared radiation. The radiation which causes heat. Very small suspended particles in the troposphere scatters visible spectrum both to space and toward the Earth's surface. This adds color to the sky. Very small suspended particles in the troposphere, that is the first layer, because suspended particles are found in the troposphere. Scatter visible suspended particles in the troposphere scatter visible spectrum both to the space and toward the Earth. So out of space, if a person goes in a space station, he will also see the Earth as blue. This versus add colors to the sky. The red color of the rising and the setting sun and the blue color of the sky are result of scattering of light within the atmosphere. The rising and the setting sun and the blue scattering of light. The spatial distribution of insolation at the Earth's surface. The insolation received at the surface varies from 320 watt per meter square in tropics to 70 watt per meter square in the poles. So the isolation received at the tropics, that is tropical places like India is a tropical place, is much more than the poles, which receive much less. And maximum isolation is received at the subtropical desert, where the cloudiness is least, so there is less resistance to the isolation, to the heat waves or the waves of isolation, where the cloudiness is least. Equator receive comparatively less isolation than tropics. Generally, at the same time latitude, at the same time generally at the same latitude, the isolation is more over the continent than over the ocean. So, generally, at the same latitude, the isolation, the same latitude, that is, imagine this one, this part. So, in this space, the area below this latitude will get much more isolation than the ocean at the same place. In winter, the middle and the higher latitude receive less radiation than summer. In winter, the middle, that is the middle one, and the higher one. Okay, this is the middle one, that is 23, this one and this one. Okay. Heating and cooling our atmosphere. There are different ways of heating and cooling of atmosphere. Earth after being heated by isolation transmit the heat to the atmospheric layer near to the earth in long wave form. The air in contact with the land gets heated slowly, and the upper layer in contact with the lower layer also get heated. This process is called conduction. So how the sun energy or the sun is responsible for the heating of earth? It is due to conduction of this due to process called conduction. Conduction takes place when two bodies of unequal temperature are in contact with one another. There is a flow of energy from the warmer to the cooler body. The transfer of heat continues until the body attains the same temperature or a contact is broken. Conduction is important in heating the lower layer of the atmosphere. So, lower layer of the atmosphere. The air in contact with earth rises vertically on heating. So, the air in contact with earth rises vertically on heating in form of current and further transmit the heat of the atmosphere. This process is called vertical heating of the atmosphere. It's called convection. The convection transfer of heat is confined to the troposphere. So convection is confined to the only to the troposphere. Transfer of heat through horizontal movement of air. Transfer of heat through horizontal movement of air is called advection. One is convection, and next is advection. So let me show you. Convection transfer of heat is due to rising of air vertically upward. Okay, and transfer of heat, this is vertical. No, this is horizontal. So convection and this is advection. The horizontal movement of air is relatively more important than the vertical movement. In middle latitude, most of the diurnal, that is day and night variation in daily weather are caused by advection alone. In tropical region, particularly in North India, during summer season, it is due to advection. Particularly in the North India during the summer season, local wind Kaldu is the outcome of advection process. Okay, now terrestrial radiation. 1 minute. Terrestrial radiation. The isolation received by the Earth in short wave form and heats up its layer. The isolation received by the Earth is in short wave form and heats up its surface. Thus, the Earth after being heated itself becomes radiating body and it radiates energy to atmosphere in long waves. So, after the energy which is received from the sun is in short wave form, but after getting heated from the Earth, it radiates the energy to the atmosphere in long wave form. What the Earth radiates it. So after being heated, itself becomes a radiating body, and it radiates heat to the atmosphere in long wave form. This heating of atmosphere from below is the process known as terrestrial radiation. Let me mark this also. Short. So isolation. Short wave form to Earth. Now from Earth, long waveform to atmosphere. So this whole process is terrestrial radiation. So moving along, the long wave radiation is absorbed by the atmospheric gases, particularly by carbon dioxide and other greenhouse gases. Thus, the atmosphere is indirectly heated by the Earth's radiation. The atmosphere in turn radiates and transmits heat to the space. Finally, the amount of heat received from the Sun is returned to the space, thereby maintaining constant temperature at the Earth's surface and in the atmosphere. Heat budget heat budget heat budget of the planet Earth. Depict the Earth. Now, figure 9.2 depicts the heat budget of the planet Earth. So 9.2. This is 8.2. I think we have something. So it is in the next chapter itself. Okay, we'll have to add that chapter. Let's add that chapter. Let's go to insert. Not here. I'll add that chapter in a new one to chapter 9. Insert a file printout. Let's see, it's okay, insert. Just wait a minute, it will take a few moments. I have a low end PC, that's why it takes a lot of time too. So we have a distribution of, this is 9.1. Now this is the 9.2. This is the budget of distribution of heat. So we are looking at, this is something 100, 015, 120, 1090. Okay, this is the latitude. This is longitude. This is near some. Okay, we'll get to this in the next chapter, chapter 9. Now let's continue with where we are. The heat budget of planet Earth. Right? Will depict the heat budget of the planet Earth. The Earth as a whole, does not accumulate or lose heat. So it does not accumulate or lose heat. It maintains a temperature. This can only happen if the amount of heat received from in the form of isolation equals to the amount of this the sun. If the amount of heat received in the form of isolation equals to the amount of lost by the Earth through terrestrial radiation. Okay. Consider that the isolation received from at the top of the atmosphere is 100%. While passing through atmosphere, some of the energy is reflected back, scattered and absorbed. Only the remaining part reaches the Earth's surface. I think that there has been printing mistake here. Figure 9.2. This is the heat budget. See the heat budget of the Earth. Consider the okay. This is we have something. This is the 100% of radiation going into the atmosphere, and some are scattered back. Scattered. These are scattered, reflected by the space, by the cloud, by the Earth itself, and absorbed. Plus 14 is absorbed. Here is 17 is absorbed. Totally, if we add all of these, 17 plus this is 50. This is 40. No, 51. 51 plus 14. And 51 plus 1, that is 65. So out of 100%, we get only 65%. Let's see if my estimates are 65 units. Is it so consider the isolation received at the top is 100%, as we read already, right? While passing through the atmosphere, some of the energy is reflected and scattered and absorbed. Only the remaining part reaches. The Earth's surface. Roughly 35 units are 35 units are reflected back to the space before even reaching the Earth's surface. Out of this, 27 are reflected back from the top of the cloud, and 2 units from the snow and ice covered areas of the Earth. The reflected amount of radiation is called albedo of the Earth. The remaining 65 units are absorbed. 14 units within the cloud surface. Within the 14 units within the atmosphere and 51 units by Earth's surface. The Earth's radiation receives 51 units in the form of terrestrial radiation. So, out of remaining 65 units are absorbed. 14 units are absorbed within the atmosphere, and 51 units are absorbed by the Earth's surface. The Earth radiates back 51 units in the form of terrestrial. 51 units is radiated back in the form of terrestrial radiation. Of these, 17 units are radiated back to the space directly, and the remaining 34 units are absorbed by the atmosphere. Once again, 6 units are absorbed directly by the atmosphere, 9 units through the convection and turbulence, and the 19 units through the latent heat of condensation. 48 units absorbed by the atmosphere, that is 14 units from isolation and plus 34 units from the terrestrial radiation are also radiated back into the space. Thus the total radiation returning from the Earth, that is 65, and the total that is 17, and atmospheric respectively is 17 plus 48, that is 65 units, which balances the total 65 units received from the sun. This is termed the heat budget or the heat balance of the Earth. This explains why Earth neither warms up nor cools down despite the huge transfer of heat that takes place. So we haven't did this part. So this is the short wave radiation that we receive from the isolation, and this is a long wave that is radiated back. So this is, as we got only 65 unit. Out of this 65 unit, let's see how much is reflected back. So from the this is radiated back. Now 6 is absorbed by the atmosphere, 17 is to the space. Okay, another 19 is totally condensation, is absorbed through condensation. So let's go to the next part. Variation in the net heat budget at the Earth's surface. As explained earlier, these are variation in the amount of radiation received at the Earth's surface. Some part of Earth has surplus radiation balance, while other part has deficit. Let's read it once again. Variation in the net heat budget. Variation in the net heat budget at the Earth's surface. As explained earlier, the variation in the amount of radiation received at the Earth's surface. Some part of the Earth has surplus of radiation balance, while the other has deficit. Okay. Figure 8.3 depicts the latitudinal variation in the net radiation balance of the Earth. So latitude variation, that is latitude. This is okay. Okay, there is a surplus here, surplus of radiation. The figure shows there is a surplus of net radiation balance between 40° north and south, and the region near the poles have deficit. The surplus heat from the tropics is redistributed polewards. As a result, tropics do not get perceptibly heated up due to accumulation of heat, or high altitude gets permanently frozen due to excess deficit. So that is not the case. Some of the heat is, that surplus of the heat is transferred to the poles. So we have 17. There's no power. The temperature. The interaction of isolation with the atmosphere and the Earth's surface creates heat, which is measured in terms of temperature. The interaction of insolation. The interaction of insolation with the atmosphere and the Earth's surface creates heat, which is measured in terms of temperature. While heat represents the molecular movement of particles comprising a substance, the temperature is measurement in degree of how hot or cold a thing is. Factor controlling temperature distribution. The temperature of air at any place is influenced by the latitude. Firstly, the latitude of the place, the altitude of the place, and the distance from the sea. Distance from the sea, that is air mass circulation. This is the process that happens. And lastly, the presence of warm and cold ocean current. The presence of warm and there is one more, and local aspect. The latitude. The temperature of the place depends on the isolation received. It has been explained earlier that the isolation varies according to the latitude, hence the temperature also varies. This is the main reason. This is the topmost region due to for the factor of isolation's topmost region. That is the latitude. Now the next one is altitude. That atmosphere is indirectly heated by terrestrial radiation from below. Therefore, the place near the sea level records higher temperature than the place situated at higher elevation. In other words, the temperature generally decreases with increase in height. The rate of decrease of temperature with the height is 6.5 degrees Celsius per thousand meters. That is 6.5 centigrade per kilometer as we go vertically upward. The distance from the sea. Another factor that influences the temperature is the location of the place with respect to the sea. Compared to the land, the sea gets heated slowly and loses heat slowly. The land heats up and cools down quickly. Therefore, the variation in the temperature over the sea is less. So the variation in the temperature over the sea is less compared to land. The place situated near the sea comes under the moderating influence of the sea and the land breeze, which moderates the temperature. Air mass and ocean current. Like the land and the sea breeze, the passage of air masses also affect the temperature. The place which comes under the influence of warm air masses experiences higher temperature, and the place that comes under the influence of cold air masses experiences low temperature. Similarly, the place located on the coast where the warm ocean current flows record higher temperature than the place located on the coast where cold current flows. Now the next is the distribution of temperature. Now the global distribution of temperature can be well understood by studying the temperature distribution in January and July. The temperature distribution is generally shown on a map with the help of the isotherms. With the help of the isotherms, isotherms are the lines joining place having equal temperature. Okay. Figure 4.814 and B shows the distribution of air temperature in the month of January and July. Let's see. This is for the month of January. So where is the isotherm? Okay, this is the isotherm. So this has this line. The area below this line has a temperature of minus 25 degrees Celsius. Another that is mostly this way. This is above Canada, follows Canada and Greenland. Okay, I'll switch it off. So I'll continue this. So as we are seeing, basically the isotherms are a line joining places having the same equal temperature, as shown in this diagram. This is for diagram for January and this is for July, month of July. And range of temperature between January and July. Sorry due to this. Okay, let's go. In general, the effect of latitude on the temperature as well as uh, in general the effect of latitude on temperature is well pronounced on the map. As the isotherms are generally parallel to the latitude, so isotherms are generally parallel to the latitude. The deviation from the general trend is more pronounced in January than in July. So in January there is basically more deviation from the general trend. So as we see, this 25 line is more curved than in around this place. See, there is more deviation in this one, and these lines are basically parallel to the latitude because this is of July. Okay, especially in the northern hemisphere. Deviation in general, okay, in the northern hemisphere, the land surface area is much larger than the southern hemisphere. Hence, the effect of land mass and the ocean current are well pronounced. In January, the isotherm deviate to the north over the ocean and to south over the continent. So, in January, this isotherms line deviate toward the land, toward the south in the continent, and toward the north. See, in the January, the isotherms are deviated toward the north over the ocean. So wherever it is over the ocean, these lines are deviating toward the north, and vice versa is for the isotherm lines over the continents. They are deviating toward the south. These uh, these are basically over the continents and the ocean, all the same. That's why it's equally parallel to the latitude. And to the south over the continent. This can be seen in the North Atlantic Ocean. North Atlantic Ocean. The presence of warm ocean current, Gulf Stream, and the North Atlantic Drift makes the Northern Atlantic Ocean warmer, and the isotherm bend toward the north. Over the land, the temperature decreases sharply, and the isotherms bend towards south in Europe. It is much pronounced in the Siberian plain. That means January temperature along 60 degree east. That means the January temperature along 60 degree east latitude minus 20 degrees Celsius, both at 80 degree north and 50 degree uh, 50 degree north. Okay, this means the monthly temperature for January is 27 degrees Celsius. In the equatorial ocean over 24 degrees Celsius in the tropics and 2 degrees to 0 degree in the middle latitude and 18 to minus 48 in the Eurasian continental. So this is the Eurasian. The effect ocean is well pronounced in the southern hemisphere, hence the isotherms are more or less parallel to the latitude, and the variation in temperatures is more gradual in the northern hemisphere. The isotherms of 20 degrees Celsius, 10 degrees Celsius, and 0 degrees Celsius run parallel to 35 degree to 35 degrees south and 45 degree south and 60 degree south latitude, respectively. Okay. This is 20 degree. This is in 10 degrees Celsius and 0 degrees Celsius. The isotherms run parallel to 35 degree. That is, it is running parallel to 35 degree. This one is 35 degree, this is 45 degree, and this one is okay. In the July isotherm generally runs parallel to the latitude. The equatorial ocean records warmer temperature more than 27 degrees Celsius. Over the land, more than 30 degree is noticed in the subtropical continent region of Asia. Along the 30 degree latitude, along the 40 degree north runs isotherms of 10 degrees Celsius, and along the 40 degree south, and the temperature is 10 degree. 8.5 shows range of temperature between January to this is showing from January to July. So this is the isotherm. This is basically the temperature here is 40 degrees Celsius. Average, I think, is range between showing the average temperature. Here is so the highest range of temperature is more than 60 degree, covering northeast part of Eurasian continent. Northeast part of Eurasian. Okay, this one is Eurasian is 60 degree. Sixty one is the northeastern part of Eurasian. Northeastern part. This is the northeastern part. Okay, this is the northeastern. This is due to this continentality, the least range of temperature, that is 3 degree Celsius, is found between 20 degrees south and 15 degree north. 20 degrees south, and 15 degree north. 15 degree north. 15 degree north. Inverse of temperature. Normally, temperature decreases with increase in elevation. Temperature decreases if increase in elevation. It is called normal lapse rate. It is called normal lapse rate. At the time the situation is reversed, the normal lapse rate is inverted. At times the situation is reversed, the normal lapse rate is inverted. This is called inverse of temperature. It is called inverse of temperature. Okay. The inversion is usually short duration but quite common nonetheless. A long winter night with clear skies and still air is ideal situation for inversion. So a long winter night with clear skies and still air is ideal situation for inversion. The heat of the day is radiated off during the night. and by early morning hours the earth is cooler than the air above. Over polar region temperature inversion is normal throughout the year. Over polar region temperature is okay. The surface inversion promotes stability in the lower layer of the atmosphere. Smoke dust particles get collected beneath the inversion layer and spread horizontally to fill the lower strata of the atmosphere. Dense fog in the morning a common occurrence, especially during winter season. This inversion commonly lasts a few hours until the sun comes up and begins to warm the earth. The inversion takes place in hills and mountains due to air drainage. The cold air at the hills and the mountains produced during night flows under the influence of gravity being heavier and dense. The cold air act almost like water and moves down the slope to pile up in the deep pockets and the valley bottoms with warm air above. This is called air drainage. It protects plant from frost damage. The Planck's law states that the hotter a body, the more energy it will radiate. Shorter the wavelength of that radiation. A specific heat. Let me get rid of this because I know this is the important because due to prelims in the science section they might ask you. The specific heat is the energy needed to raise the temperature of 1 gram of substance by 1 degree Celsius. That is the specific heat. And the specific heat of there's one more reason. There's one more question. Like there's a question like won't boiling water at 100 degrees Celsius won't burn your hand severely than the steam 100 degrees Celsius steam. This is due to the specific heat of the steam is more than the boiling water. This is we have read in class 7 or 8 something. Yes, the sun is directly overhead at noon at 21st June uh, at the June it is I think it is for the directly overhead noon in 21st June. Let's see the somewhere here. Okay, it is not here. One point nine conduction. No. Two Hudson days. The summarize. Solstice. 47 degrees Celsius. No, I haven't seen that anywhere. If I did, had I could not remember that division with the temperature. No. Let's see. Answer. Let's leave it. If I want to guess, it would be this one. Let's Lucy at 23 degree 20. Which one of the following cities are days that has longest? I think the longest night is suffered at Chandigarh because it is at northern part of the India. Atmosphere is mainly heated by Atmosphere is mainly heated by scattering solar radiation. Atmosphere is mainly heated by shorter waves. Shortwave solar radiation is could be the answer, and this is the answer. Long wave radiation. No, 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 no. Let's confirm this. There are different way of heating and cooling the Earth after being heated by insulation transmit heat to the atmospherically near the Earth. Okay, okay. So, so this is not the long wave radiation. The atmosphere is. Less insolation. Insolation is a line. Incoming solar radiation is called the insolation. Okay. Albedo is the long difference between isotherm difference between a long joining the place of equal temperature is called isotherms. Annual range. The percentage of visible light reflected by the percentage of visible light reflected by an object. This difference between annual range. Yes. Difference. So albedo is the percentage of visible light reflected by an object. Let's confirm this. Albedo. I have seen this somewhere here. Oh, no. The amount of radiation, the reflected amount of radiation is called albedo of the Earth. So percent of visible reflected by. Okay. The main reason for the Earth experiencing high temperature in the subtropical in the northern hemisphere rather than its equator is to have less cloud. No, no, no. Subtropical areas longer days, hour in summer than this could be the reason. Okay. Subtropical has no. Subtropical are near to the ocean region and the equatorial. This is the right answer. I don't know if I'm wrong. It's the main reason for the Earth experiencing high temperature in the subtropic in northern hemisphere. Subtropic in the northern hemisphere. Subtropic in the northern hemisphere. So, northern hemisphere has no oceanic areas. So the answers could be the traditional less cloud over the equatorial. This could be the answer. Subtropical have longer days, hours in the summer than the equatorial region. Yes. Let's go to how does the wait. This one more thing. Enormous split. Mainly in the Earth's very high temperature is subtropical. Oh. Okay, that's about it. How does the unequal distribution of heat over planet Earth over space and time cause variation in the unequal distribution of Earth?
Oh shit.